Hello, I am Abdulwahab Felemban, a master's student at the Information System Lab at KAUST. Today, I will introduce to you our work on the Smart Tap, an application of human action anticipation. In our daily life, we started to leave the water running from the tap without feeling how important and valuable that resource we are wasting. Water taps are not optimally designed to save water. The infrared tap is an important invention that tried to address this, but all of us was in that situation where you try to figure out how to place your hands to make it work, as well it has turning off delay resulting in water waste. This motivates why we proposed our Smart Tap solution. It saves water, allows seamless experience that can be personalized to perfectly fit your water usage. The Smart Tap uses depth cameras to localize body joints in the form of a human skeleton. Then using a deep learning models, we can recognize what a person is doing to have a real-time control of water tap, turning it on and off right on time. The depth camera provides us a set of joints in a three-dimensional space. We can see these human skeletons as graphs. A graph consists of vertices and edges connecting them. The localized body joints can be seen as the vertices on the graph, and the bones connecting them as the edges. There's a special deep learning model that deals with such data types. It's the graph convolution networks. Unlike CNNs with their nature of looking at local neighbors around pixels, in GCNs we define this locality through defining an adjacency matrix based on the edges and the graph. GCNs outperform CNNs marginally on different human activity recognition datasets with available depth modality. The GCNs models takes a temporally stacked skeletons as its input and perform classification on that. But having a GCN that recognizes actions is not the end of the story. Our task is to control the tap in real time. So we need to compensate for the mechanical system delay in controlling the tap and the inference time of the used model. That's why we need human action anticipation. We want to anticipate the action of the person, giving some recent data period to that action. So we generated our own dataset. We focused on wudu, which is the ablution that Muslims daily do. We generated 5 hours worth of annotated videos, and the performance did wudu with different speeds, as well no consistent durations, giving us diverse, realistic data representation. We trained and fine-tuned a spatial temporal graph convolutional network with a few number of inputs, 20 frames. And we did simple trick to consider anticipating future actions. We changed the ground truth label to be the future action that will happen next, rather than the action of the current 20 frames. In this sense, we allow the water tap to operate in real time. This table shows some of the classes in the dataset. And on the right, we can see how the STGCN block looks like, implemented using CNNs with a predefined adjacency matrix. So we wanted to sense how good this solution is. Through experiments, taking the infrared tap as a reference, the AI model with binary classification to turn on and off the tap saves around 7% more water. And the multi-class classification tap that can control water pressure based on the need can save up to 43%. Both the turn on and off tap and the different water pressure tap are more convenient to use, giving us more seamless experience and hence a faster wudu experience. This is the IR tap. You'll see how inconvenient it gets sometimes to turn it on and the delay in turning it off. And here's our Smart Tap solution. We used STGCN classification output to control the tap. Smart Tap is one solution based on human action anticipation, but there are many other applications, like human-robot interaction. It is very important to recognize human action in real time to automate a decision based on that, or in predicting pedestrians' behavior in self-driving cars to understand their intentions before they cross the road. That was the spotlight presentation about Smart Tap. Please feel free to contact me if you have any questions. And thank you for your attention.